I welcome you at the Dimitra farm, which is outside Thessaloniki area in Greece. This is the SPADE project, and the pilot that you are seeing, it's the livestock pilot of this European project. In the next few minutes, you will follow a certain number of interviews from scientific personnel, from end users, farmers, and from industrial partners, technology contributors that provide solutions and in the end make the livestock pilot a reality.
Sheep farming is an essential component of the ecosystem services in the island of Lesbos and also adds significantly to the island's cultural and gastronomic history. Animal breeding in the island of Lesbos exists over thousands of years, with reports back from Homer for the exquisite quality of cheeses even at that time. Due to several factors, some of which are related to the local topography, but also land use and ownership, the majority of animals are kept in the northwestern part of the island. It should be also noted that many areas in the island of Lesbos are designated as Natura 2000 protected areas where no such an activity can exist. Therefore, management of the available but rather limited natural resources, such as grazing land and pastures, is critical. This pilot case provides an opportunity and a use case scenario where multi-purpose drones or aerial means facilitates the monitor of grazing animals, but also monitoring animal health and as well aid in overall livestock management. Aerial surveillance and data collection can aid in optimization of grazing rotational schemes that will increase milk yield and quality. It can also contribute to the authentication, tracing and conservation of traditional production systems and sheep farming in the islands of Lesbos, which has several TPO, designated protected designated origin products. In simple terms, aerial means can be used to monitor two main parameters. One of them is the animal themselves, and the other one is the pasture lands and even natural water depots. When animals are grazing freely, you can use drones to monitor their animal location, the animal distribution, their number, and potentially detect stray animals that move away from the herd. Regarding pasture, drones can be used to quickly assess the grazing capacity of each particular location, distinguishing areas with low or high quality of pastures, especially if the drones are equipped with multispectral cameras, thus providing an evidence-based decision support system that can identify areas which are mostly visited by animals. Finally, the proposed technology aspires to improve the working conditions of the local farmer, but also entice younger generation to engage in a traditional sheep farming by offering a platform capable of providing a robust decision support system and minimizing the effort required for everyday tasks.
Weather conditions, especially temperatures and sunshine, affect the grazing behavior of animals. High temperatures are associated with low grazing activity, resulting in sheep grazing early in the morning and late in the afternoon. To cope with heat stress, sheep also tend to spend more time grazing near the water and shade locations. Vegetation largely affects also the behavior of grazing animal as well as productivity and quality of pasture land. The vegetation of sheep pasture land ideally should consist of about 60 to 70% of plant species belongs to the Poaceae family, like Avena sterilis, Festuca ovina, Lolium perens, and 30 to 40% of legumes such as Trifolium repens, Medicaco sativa, and Medicaco lupulina. Drones provide real-time aerial monitoring of pasture, helping farmers identify land moisture, overgrazing, and plan grazing rotation more effectively. Drones equipped with a sensor can collect data on vegetation quality and quantity, soil moisture and other environmental factors. Moreover, drone can design dynamic visual fences, enhancing animal safety and welfare while ensuring rational management of pasture. These virtual fences ensure that livestock have access to sufficient grazing material, water and shade, optimize their well-being, while also preventing overgrazing and promote sustainable land management. Acting as virtual shepherd, drones inspect grassland for suitability and accessibility, even in remote or difficult to reach grazing area without the need of extensive manual labor or vehicle usage, saving time and resources. Finally, drones can also collect data at a population level, including distribution, tracking, and counting of the flock.
Drones offer a lot of capabilities in livestock farming, however their use is associated with inherent risk. For example, drones can cause stress or disturbance to the animals, especially if they are not accustomed to their sound or sight. Moreover, drones flying over pasture or over grazing animals may again cause stress and disturbance and disrupt their natural behavior, such as resting or feeding. The use of drones may also cause harm or injury to animals, either directly through collisions or indirectly through the stress and disturbance they produce. For example, animals may attempt to escape their enclosures, hurt each other during this process, or even cause some damages to the infrastructure. Drones also may affect guardian animals, such as dogs, which may perceive the flying devices as threats or intruders, and they may attempt to attack or even chase the drones or the operator. Drones equipped with cameras raise also some privacy concerns to farmers and to adjacent property. Depending on the location, there might be regulations restricting the use of drones, especially in the livestock setting or near animals.
Just observe the commercial drone that we have purchased, and it will be part of the University of Thessaloniki test. The challenges that we are facing, as mentioned before, relate to the way that we will interface the existing equipment on board the Parrot. This is commercial drone. This commercial drone has, apart from an RGB camera, also an infrared camera. Apart from that, we will be able to extract from the drone live streaming video, the location of the drone, and of course the timestamp that would allow us to correlate information coming directly from the animals and information that comes from the drone. So this is a challenge that we will be implementing during the livestock pilot. Other more practical issues, as mentioned earlier, relate to the way that we need to handle battery consumption. Battery consumption in the presence of edge computing is very significant because it may significantly deter the range of the drone itself, and of course it will also limit the monitoring time for the flock that we will focus on.
Okay, this is the custom-built drone that SDU made for the SPADE project. This custom-built drone has a flight controller which controls how it's stabilizing in the air, and a lot of antennas so we can communicate with it on the ground. For example here, and then it uses the GPS, and it uses a GPS, and the most important part is that we have an edge computer on board, so we can do something autonomously or do live or real-time calculations or computing. Additionally, we have 2 cameras on it, one FPV, so we can see it on our controller when we're flying it, what the GoPro will see, because the GoPro is taking higher resolution or higher quality videos that we can use afterwards for post-processing.
So to be honest, farmers are not aware about the advanced capabilities of drones, with the exception perhaps of spraying drones, which are used in pastures, like the one behind me, or in crop farms. So after a visit in the Lesbos Island and introducing the SPADE project to them, they started discussing with us and tell us what they expect from us actually. So they want drones to help them in pasture management, in animal tracking, search and rescue missions of animals, in precision livestock farming, and if possible in early disease detection. They also expect drones to help them perform these daily activities with reduced costs and, if possible, much quicker than they actually do. However, farmers explicitly mentioned their concerns about drone flight emissions in terms of drone handling, data privacy and security, the disturbance they cause to animals, and the user-friendliness of the SPADE platform.
Γεια σας, ονομάζομαι Κουλουδής Χρήστος και είμαι γεωπόνος ζωοτέχνης. Τα τελευταία 7 χρόνια ζω στο νησί της Λέσβου. Η Λέσβος είναι ένα νησί όπου η προβατοτροφία είναι ο δεύτερος σημαντικός οικονομικός παράγοντας για την οικονομία του τόπου. Στη Λέσβο, τα αιγοπρόβατα ζουν κυρίως σε ορεινές περιοχές και έχουμε εκτατικές μορφές.
The SPADE Livestock platform will integrate the data collected by drones and sensors. This can help the farmers to assess the farm environment and managerial aspects. The SPADE platform will integrate and analyze data and also produce reports for the farmers to properly act on. The SPADE platform can help the farmers in optimize the grazing and inputs such as water, feed or medication. It can also help them to detect early animal diseases and act properly on, and potentially to help them in predicting seasonal fluctuations of forage availability. However, I have to stress out that the platform, in order to be useful for farmers, should be able to provide simple reports without the farmer having to take significant actions. So to put it simply, the report should be available with just a few clicks for the farmer.